The Harvey residence was built in 2010 and 2011 and is located at 504 Geneva Avenue in Boulder, Colorado. It is an example of sustainable design and construction in almost every aspect. Radiance Corporation of Nederland, Colorado was selected as an energy efficiency consultant and mechanical systems project manager in the design and construction of this showcase home. The Harvey residence was designed by Boulder architects Brian Fuentes and Corey Nielsen. Construction was by Mod Verde. The home features a modern open floor plan, use of sustainable materials, a high-performance building envelope, and renewable energy systems such as solar and geothermal. Pam and Dan Harvey are the proud owners of this fine, healthy, and sustainable home. Their vision and commitment to a sustainable approach was established at the outset of the project and followed through down to every detail in the choices they made along the way. The Harvey residence is a collaborative combination of top local talent in the sustainable home building industry. From striking architectural design by Brian Fuentes and Corey Nielsen, to careful construction management by Dante Medri and Lee Carmichael of Mod Verde, to a highly talented mechanical team led by Radiance Corporation, care was taken at every stage to ensure innovation in design and construction and excellence in sustainability. The heating and cooling plant is anchored by a two-stage geothermal heat pump, using the steady ground temperature in the backyard to save approximately 75% of the energy required to heat and cool the home. The geothermal heat pump produces hot water for heating, chilled water for cooling, as well as domestic hot water when the sun isn't shining. The geothermal heat pump system qualified for a 30% federal tax credit. The geothermal heat pump system is connected to a horizontal ground loop heat exchanger, buried 7 feet below the backyard. The horizontal ground loop heat exchanger cost approximately 20% less than the cost of drilling and was installed by PK Geothermal of Erie, Colorado. Seward Mechanical Systems of Louisville, Colorado designed a radiant floor heating system that doubles as a radiant cooling system in the summer. There are 7 separate zones, each with its own thermostat, permitting precise climate control and economy of operation. Radiance Corporation designed a custom control strategy using a dew point alarm to ensure that the radiant cooling is suspended if the home comes close to a dew point during cooling, whereby cooling water to the floor is suspended and second stage airside cooling comes on to dehumidify. Fuentes' design favors the utilization of steel pan decking in its floor construction to reduce framing resources. Radiance and Fuentes agreed to install spray foam insulation on the pan decking to bolster the radiant heating and cooling performance. The tubing used in the radiant floor is a special type called PEX-AL, which uses a protected aluminum foil oxygen barrier. PEX-AL also reduces head pressure of the system by about 15% compared to other radiant tubing, reducing pumping energy requirements. Heating or cooling water is circulated using variable speed pumps, further reducing pumping energy requirements. Individual thermostats in each of the 7 zones controls the flow of heating or cooling water to the radiant floors by turning on or off its associated zone valve. Hydronic flow rate is controlled using variable speed circulation pumps. Cooling water set point temperature is dynamically changed based on slab temperatures by modulating the position of a 3-way mixing valve. Custom Solar of Boulder, Colorado installed a top-of-the-line solar thermal system using Wiesmann collectors, pump station, and differential control, and a propylene glycol approach to freeze protection. Heated water is stored in a stainless steel solar storage tank. Copper coil heat exchangers in the solar storage tank permit heated water to be sent to the domestic hot water system, the radiant floor heating system, as well as to the geothermal ground loop heat exchanger in a sequence called solar banking. Radiance Corporation designed a control system that leverages several energy-efficient control strategies. First, the geothermal heat pump is staged, so it operates at part load most of the time. An outdoor air reset control determines the lowest temperature water needed to heat the home in response to changing weather conditions. Cooling is locked out in cold weather and is only allowed by an automatic calendar scheduler. Energy recovery ventilation comes on to exhaust bathrooms and dynamically in response to high carbon dioxide levels. And the geothermal system is fully integrated with the solar thermal system, effectively using the geothermal system as a backup system for the solar thermal. Radiance Corporation implemented a solar banking system, integrating the geothermal and solar thermal heating systems. Excess heat from the solar thermal system is sent to the domestic hot water tank, the radiant heating buffer tank, and to the ground loop heat exchanger. This solar banking approach continuously sends solar heat where it will be needed next. It synergistically increases the efficiency of both the geothermal heating system and the solar thermal system in unison. Energy recovery ventilation is used to precondition outside ventilation air using heat from the exhaust air stream. The exchange of heat taking place in a special cross-flow heat exchanger. The energy recovery ventilation comes on to exhaust bathrooms whenever a user operates a push-button timer. A fan coil interlock control also brings fresh air into the home at a set percentage of the time, and a CO2 control in the living room controls the ERV dynamically in response to changing carbon dioxide levels due to changes in occupancy. Natural Homes of Nederland, Colorado installed soy-based spray foam insulation, greatly enhancing the energy efficiency of the building envelope. Heat loss by conduction is significantly reduced with very high R values. The spray foam also greatly reduces infiltration heat loss. A blower door test performed by Populous of Boulder, Colorado, reported a wind-loaded infiltration rate of just 1.23 air changes per hour at a pressure of 50 pascals. The Harvey residence utilizes significant areas of glazing for natural daylight, complemented by shading features to reduce summer heat gain. Fuentes Design took great care in the design and selection of the glazing. Glass U value and shading heat gain coefficient of each piece of glazing is matched to the heating and cooling loads of each room in the home. The windows, provided by Sirius Materials, utilize fiberglass frames and selective coatings to achieve outstanding tested performance characteristics. Given the high insulation levels and superior glass of this home, the geothermal heat pump system capacity was reduced by about 1/3, greatly reducing both first costs of the mechanical systems and ongoing operating costs of the heating and cooling. Lighthouse Solar of Boulder, Colorado installed a 10 kW solar photovoltaic system. The Harvey residence incorporates 3 green roof areas featuring native vegetation, helping to bring the feeling of the outdoors into the home while better managing drainage from the structure. These innovative green roofing systems were installed by Green Roofs of Colorado. The Harvey residence features energy-efficient lighting technologies throughout, including extensive use of LED and fluorescent lighting designs. Another innovative energy efficiency feature is the ethanol fireplace, which requires no chimney and no outside combustion air. There is no natural gas supply to the house either, reducing fossil fuels usage and saving a monthly service charge. The Harvey residence is a showcase of sustainable outcomes in home design, construction, energy efficiency, and indoor air quality, and achieved a home energy rating system of 4.